For this video, I picked out 4 different multiple choice questions geared mainly towards momentum and impulse. So hopefully you guys have done those topics. With this first one, I want you to guys remember, well, 2 key facts. Whenever you multiply the same type of function, what I mean by that is if you multiply a scalar by a scalar, or if you multiply a vector quantity by another vector quantity, in both cases, you're going to end up with a scalar. So this second one is what confuses students the most. If you do something that you know is a vector like acceleration multiplied by something else that you know is a vector like force, the product will be a scalar. What about if you multiply 2 different types of quantities? For example, a scalar times a vector or a vector times a scalar. Well, that's the case where, some write v times s for vector times scalar. In both of these instances, the product will be a vector. So let's break these equations down. We know impulse is force multiplied by time. You are expected to know that force itself is a vector. Actually, I'm going to change the thickness of the pen. I think this is too thin. So force is a vector, and we're multiplying it by a scalar. So when you multiply 2 different types of quantities, that always gives a vector. So we know it's definitely either C or D. Let's now move on to force. Well, an easy equation for force is mass times acceleration. Again, breaking down mass times acceleration, we know mass is a scalar, and you're multiplying it by an acceleration, which is a vector. A scalar times a vector will be a vector, and so force is a vector too, meaning option D is the correct answer for part 1. Moving on to the next question. This one relates more so to momentum and impulse. It's telling us what the rate of change of momentum of an object falling freely under gravity is equal to. Well, let's think about it. We know impulse, force times change in time, I wrote just time, is equal to change in momentum. Well, because momentum is mass times velocity, and during an object's motion, the mass is almost always constant, a change in momentum is caused by a change in velocity. So we can say that the change in momentum is mass times change in velocity. We can then rearrange to get the rate of change of momentum, which is the change in momentum over time. And once you get that on the right-hand side, we get that it's equal to a force. Let's now think about what force acts on a body that falls freely under gravity. Freely under gravity means the only force acting on it is gravity. And what force comes as a result of gravity? Well, it's the weight, which is equal to the mass times gravity. And so that's why weight is the correct answer in this instance. Moving on to the next question. I'm moving quite fast. A force F varies with time t, as shown in the graph. It's initially at rest on a smooth surface, meaning there's no friction. What's the momentum of the body after 5 seconds? So once again, momentum is mass times velocity. After 5 seconds, what this is requiring to use is the fact that the momentum itself is equal to impulse, which is force multiplied by time. And that's why it's giving you a force time graph. How can we find the impulse after 5 seconds from this graph? Well, like I mentioned, the multiplication of the axes is what gives the impulse. So that's like the area under the graph, which is basically the area of this triangle. That's the base of 5 multiplied by the height of 10, all divided by 2, which is 25. That means that there's 25 Newton seconds of impulse, and there's 25 kilogram meters per second of momentum. So mass times velocity is equal to 25. It then asks you for, that's all it asks for. So it's option C. Perfect. If it asks you to then find something like the velocity, you can divide both sides by the mass, but it hasn't really given you a mass here, and it hasn't asked you to do that, so we don't have to do that. Typically we do have to, but yeah, in this question we don't. Moving on now, we have 2 more questions, by the way. Okay, this is a really good question. So it tells you particle of mass m strikes a wall with a velocity v. If a collision is perfectly elastic. So what does elastic mean? It means that kinetic energy is conserved throughout the interaction. That means that the kinetic energy before it hits the wall is equal to the kinetic energy after it hits the wall. And we can actually use this to form an expression. So let's think about what happens after it hits the wall actually. Well, because it's an elastic collision and kinetic energy is a half mv squared, the mass of the ball is constant throughout the whole journey. If it has a variation, kinetic energy is only due to a variation in velocity. But because it's a completely elastic collisions and the kinetic energies are equal and the masses are equal, that means that the squares of the velocities are equal. That means that the speed is equal. But is the velocity equal if the speed is equal? No, actually, because Although it's going to have the same magnitude of velocity v, it moves in the opposite direction, meaning the velocity is minus v. In that case, we say, as a result of the collision, well, the change in momentum, we know momentum is mass times change in velocity, and that's equal to mass times the change in velocity between v and minus v. If we think about it, to go from v to minus v, you have to take away 2v, right? And that's what tells you that the change in velocity is 2v, 2mv. And then because we're multiplying a positive and a negative, it will be a negative change, meaning that it will be to the left. So it's 2mv to the left. Quite a difficult question there. So be careful of dealing with velocities and directions. Lastly, it tells you there's a resultant force time graph. It tells you the mass of an object that's initially at rest, and it asks for the speed of the object after 1 second. Well, the fact that force and time is given means that you can multiply the area under the graph to get force times time, which is the impulse. So let's do that. The total area under the graph, well, the area of this rectangle, which is 0.5 times 5, we add onto that the area of this larger rectangle, which is 0.5 times 15. So let's do that. 0.5 times 5 is 2.5, plus 0.5 times 15 is 7.5, and that's all equal to 10 Newton seconds. We want the speed. Let's break this down. We know that the impulse, 10 Newton seconds, is equal to the change in momentum, because that's an equation that we've been using throughout today. Now the change in momentum is the mass times change in velocity. How does this help us? Well, first of all, it's given us a mass, so let's substitute that in to get that 10 is equal to 2 times change in velocity, and the change in velocity is equal to 10 divided by 2, which is 5 meters per second. If we get that after 1 second, there's a change in velocity of 5 meters per second, and that is initially at rest, meaning its initial velocity is 0. So it's initially has a velocity of 0, but then its velocity changes by 5 meters per second due to this whole interaction, and so therefore the velocity becomes 5, because it gains 5 from 0 to become 5. Yeah, I sort of made that up along the way because, yeah, I didn't do this question before, but yeah, hopefully that made sense and it all fit together like a puzzle. If this video helped, be sure to like it and subscribe. I'll post more content like this very soon. I appreciate you for watching.